In this ShowMe, I'm going to derive the infamous quadratic formula. To do that, we're going to solve ax squared plus bx plus c equals 0 if a is not 0. Notice that in this equation, I have specified absolutely none of the coefficients. The only numbers we can be sure of are the exponents on x, wherever it appears, and 0. In every other way, this equation is completely independent of any specific numbers that we know. There is one rule: a cannot be 0. There are two reasons for that. First, if a is 0, this isn't a quadratic equation anymore, because there won't be a square term left. Secondly, we're going to need to divide the entire equation by a at some point. Obviously, we cannot divide by 0. But since a is not 0, there will be no barriers to accomplishing that. If we were solving this problem in an assignment, we would begin by looking for shortcuts or easier ways to solve the equation. The last resort would be completing the square, since it involves a fair amount of work and can lead to fairly complicated looking answers. Nonetheless, the only way to solve it when you have no idea what the numbers in front of x squared and x are is to use completing the square. To complete the square, there are two things we have to accomplish before we can use the skill. First, we have to clear the coefficient of x squared, and then we have to clear the constant. To begin with, then, let's divide both sides by a. That means the left side will be x squared plus b over a x plus c over a equals 0. Now to clear the constant. The constant is the term on the left side that has no x. So we're going to get rid of c over a. And we're going to leave a space there because we want to make sure that we have room to write the new number we're going to have to add to turn the left side into a perfect square. So, at the end of our first frame, we're going to have x squared plus b over ax equals negative c over a. Now it's time to pick the number we're going to add to both sides to turn the left side of this equation into a perfect square. Now we're ready to complete the square. To complete the square, we have to take half of the coefficient of x and square it, and add that result to both sides. Well, half of b over a is b over 2a. And the square of b over 2a is b squared over 4a squared. And we're adding that to both sides. On the left side, we've created an expression that factors easily. It's x plus b over 2a squared. On the right side, we have two fractions that we need to add. They need a common denominator. Let's make that happen. The common denominator for a and 4a squared would be their least common multiple, and their least common multiple is 4a squared. So we don't need to do anything to the right side fraction. It's already in the correct form. The left side fraction, however, needs to be changed in appearance so that we can see that it has the same denominator as the other fraction. Well, I'd like to turn a into 4a squared, and this sort of conversion can only be done using multiplication or division. What would I multiply that a by to get 4a squared? I think we should use 4a, because a times 4a is 4a squared. So we're going to have 4a squared on the bottom. We're going to have b squared on top. And then we're going to have negative c times 4a, which is being added to that, so that's b squared minus 4ac. Now we've written the right side as a single fraction. Now it's time to take the square root of both sides. Well, the square root of the square of x plus b over 2a has to be x plus b over 2a. On the right side, we know that every number has two square roots, a positive square root and a negative square root. We have no way of knowing whether b squared minus 4ac will happen to be a square number or not. We know that when it does, it's a pretty easy thing to deal with, but it won't always be. And since we don't know what a, b, and c are, we cannot assume that we know. So we'll leave that entire expression under a radical, under the square root sign. On the bottom, we're going to have 2a, because the square root of 4a squared is 2a. The square root of 4 is 2, the square root of a squared is a. Now we're ready to finish the job. The very last step is to subtract b over 2a from both sides. Notice that the two fractions involved here have the same denominator. That is extremely convenient. X is negative b plus or minus the square root of b squared minus 4ac all over 2a. This sentence in green is the quadratic formula. It gives a blueprint for how to solve every single quadratic equation that you can write in standard form. Notice once again that a can't be 0 because a appears as a factor of the denominator, and we certainly can't have 0 in the denominator. This formula has a lot of important implications and applications, and I'm going to explore those in later ShowMes. For now, this ShowMe was all about discovering how it is we found our way to this formula. Every step is well justified by our practice throughout the course of algebra. More detailed and more specific reasons will be required of you in your geometry class and more advanced math classes. But for now, we discovered an important strategy, an important formula for the answer, the general answer to an entire class of problems. That's a very powerful thing. It's not an unimportant thing by any stretch. And I hope you appreciate the power of this. From now on, if you really wanted to, you could simply plug this formula into a spreadsheet or an app, and you would never have to actually solve the quadratic equation again, because the application would give you the answer through this formula. That's powerful, and that's an important idea that you need to understand about math. If you are in a position to use math in your work in the future, you're going to want to create singular solutions for lots of different problems and simply refer back to the basic solution to help you generate new answers to different questions. That's sort of what we're doing here. We were looking for one simple formula that explained the answer. And believe it or not, that's a simple formula. Compared to the list of instructions that you require to complete the square, this is a big step in the right direction.